Duration of a bond's portfolio. Broadly speaking, there are two methods of coming up with the duration of a bond portfolio. The first is to use the weighted average of time to receipt of the aggregate cash flows. In other words, we consider the portfolio, we look at all the cash flows. The cash flows obviously will come from different bonds in the portfolio. So if this is your portfolio, you have several bonds. Each of these bonds has an associated cash flow, which means that overall this portfolio has a certain cash flow. We can take the weighted average of these cash flows to come up with the duration. This is the theoretically correct approach, but it is difficult to use in practice. Effectively, what we are doing here is coming up with the cash flow yield, and this is not commonly used. The amount and timing of cash flows might not be known because some of these bonds might be bonds with call options or put options. Some of these might be mortgage-backed securities which are interest rate sensitive, so the timing as well as the amounts might not be known. Interest rate risk is usually expressed as a change in benchmark interest rates, such as government interest rates, and not as a change in cash flow yield. And finally, change in the cash flow yield is not necessarily the same amount as the change in the YTMs on the individual bonds. Just remember the statement, you really don't need to get into too much detail. The approach that is used more often is shown right here. The weighted average of the individual bond durations that comprise the portfolio. So we take the durations of these individual bonds, look at the market value of each bond relative to the market value of the portfolio. That will determine the weight of each bond, multiply the weight by the duration of each bond and come up with the duration of the portfolio. Commonly used in practice, easy to use as a measure of interest rate risk. This method becomes more accurate as differences in YTMs of bonds in the portfolio become smaller. In other words, if you have a flat yield curve where the yield on shorter term bonds and longer term bonds are equal, that would imply that the yields across different bonds are similar. If this happens, then the approximate method gives an answer that is quite close to the theoretically accurate method. In fact, with a flat yield curve, the two methods will give the same answer. Also, this method assumes a parallel shift in the yield curve. In other words, it assumes that if you have a given yield curve and there is a change in interest rates, then the change in interest rate is the same across different maturities. Let us consider example 11 now. I want you to read this first. Note that we have three different bonds in the portfolio. We are given the Macaulay duration. We are also given the total market value and then some more information which makes our calculations simpler. We have a periodicity of 2. And we are asked to calculate the average annual modified duration. And this makes things slightly tricky because what is given is Macaulay duration and we are asked to find the modified duration. So one of the things that we need to do is convert the Macaulay duration into modified duration. The first thing that we need to do is take the Macaulay duration and convert into modified duration. The formula, which I hope you remember from before, is as follows. Modified duration is equal to Macaulay duration over 1 plus R, where R is the per period yield. We are told that we have a periodicity of 2 and the YTM is 9.1% or 0.09. We need to take that number and divide by 2, so we have the per period YTM. The modified duration for bond A then becomes 4.761 from here, divided by 1 plus 0.091 over 2. And then we multiply this by the weight for bond A. For the weight, we take the market value, which is shown right here, divided by the overall market value for the portfolio, which is given here. You need to do the same for bonds B and C. This is bond A. And then add the three numbers. What you should then get is 6.0495. This is the duration or the modified duration of the overall portfolio. The question then is, what happens to the yield to maturity? The question then is, estimate the percentage loss in the portfolio's market value if the YTM on each bond goes up by 20 basis points. All we do there is recognize that this is the duration, which means that if the YTM goes up by 1%, then the value will go down by 6% roughly. But here the value, or here the YTM goes up by 20 basis points, which is the same as 0.2%. So we multiply 6 by 0.2 and we get 1.21%. And this is a negative number because the interest rates have gone up and therefore the value of the portfolio will come down. We will now talk about money duration and the price value of a basis point. The money duration of a bond is a measure of the price change in units of currency in which the bond is denominated. The difference between this measure and what we've talked about earlier is earlier duration measures talked about a percentage change in the price of a bond. This measure is talking about the dollar value change or the currency value change in the price of a bond. The money duration is equal to the annual modified duration times the value of the bond. This is the full price of the bond. Note that we have modified duration over here. If you get a question where you are given the Macaulay duration, then the Macaulay duration has to be converted into modified duration. Let's do a very simple example. Say you have a bond where the full price is 100 and the modified duration is 6. This will mean that the money duration is 6 into 100, which is 600. Then the more interesting aspect is shown over here. The change in price or value of the bond is equal to, and this is roughly equal to because we have a linear approximation here, the money duration into change in yield. If the change in yield is 1%, that will mean we have a change of 0.01 in decimal terms, and applying that over here, the change in value given a 1% change in yield will be equal to minus 600 into 0.01, and this is equal to $6. Given that I used a par value of 100, 6 and 6 are the same numerically, but this 6 is a percentage and this 6 is a dollar value. We'll see a more detailed example on the next slide. The price value of a basis point is an estimate of the change in the full price given a 1 basis point change in the yield to maturity. There are two ways of coming up with the price value of a basis point. One is to take the money duration and then use a change in yield of 0.01%, which is the same as 0.0001. The other is to use this formula where we say that the price value of a basis point is equal to the value of the bond if interest rates go down by 1 basis point, minus the value of the bond if interest rates go up by a basis point divided by 2. Let's do example 12 now. Par value is 10 million and this is the price of the bond, 98.125. So it is a discount bond. We are given the YTM, and note that this is quoted on a semi-annual basis. This is actually 98.125 is the flat price. The full price is 99.65. The question is giving you more information than you need, and what is being tested is your ability to pick out the correct information or the information that is needed to solve the problem. We are also given the Macaulay duration. The question now is calculate the money duration per 100 in par value. If you recall from the previous slide, the money duration is equal to the modified duration into the full price. What is the modified duration? We can calculate this using Macaulay duration, and that is 2.4988 divided by 1 plus R. And R is half of this number because we have a semi-annual bond. What is half of this number? In decimals it is 0.0526 divided by 2. I'm just going to 4 decimal places here, multiplied by the full price. And again, I emphasize full price because you are given both the flat price and the full price. You are supposed to use the full price, which is 99.650. When you do the calculation, you should get 242.62. This is the money duration. Question 2 then is, using the money duration, estimate the loss on the position for each 1 basis point increase in the yield to maturity. As discussed on the previous slide, the change in value of the bond is equal to the money duration, and we actually use negative. So the money duration is 242.62 multiplied by the change in yield. The change in yield is 1 basis point, which is 0.0001, and this gives us 0.024262. We have to come up with the loss for the entire position. This is the loss for $100 par value. So we take this number and multiply it by the total par value of 10 million divided by 100, because this is based on $100 par value. And when you do this calculation, what you should get is 242.620. The interpretation here is that if the interest rate changes by 1 basis point, then the value of the bond will come down by 2,426.